Okay, welcome back. This is question 50 from chemistry section in 2018 IMAT past paper. So I'll be solving this question. It says a sealed container contains 1 mole of hydrogen gas, which behaves as an ideal gas. So what we must recall about the ideal gas, the main expression is that PV, which is pressure times volume, gives N the moles, R is the constant gas, and times the temperature, which is the absolute temperature measured in kelvins. So the question asks which of the following changes increases the total kinetic energy of hydrogen gas molecules initially within the container. So also we have to recall the main important expression about total kinetic energy. And the main definition is that the total average kinetic energy mainly depends on the temperature, the absolute temperature. So for every of the gas molecules in the container, which is mentioned, so for same temperature, all of the gases, regardless of their identity, their molar mass, or their like anything like the number of protons or their main identity, the kinetic energy at same given temperature is same for all the molecules in that container. So that's the only main thing we must recall about total kinetic energy. So it mainly depends on temperature and the molar mass or type of gas molecule does not affect kinetic energy. The only thing that's affected is the velocity of the gas molecule because if they have larger molar mass, so they will have lower speed, and if they have lighter, less molar mass, they will have greater velocity. So we're not gonna consider that in this part of question. We're just only gonna consider Ke is proportional to T. That's the main fundamental concept. So now moving on to the options, we must also keep in mind that they've only mentioned a specific variables, although they didn't mention any temperature throughout the question, but we still use this fundamental concept. So they use only moles, pressure, and volume, the main variables that's being changed in this question. And similarly, ATM, which is still a pressure, volume, and moles. And so these are the only variables that are being changed in this question. So to solve this, we cannot directly use Ke proportional to T, but although this is the main concept that we're gonna apply, so to solve this question, we're gonna have to substitute this expression for ideal gas, the general ideal gas formula, into this total kinetic energy expression to solve this question. So the only thing is I'm gonna get rid of this temperature T and substitute the pressure and volume that are being actually changed in the question. So ideal gas law. So as we have recall, it's PV is equal to nRT, and for the average kinetic energy or total Ke kinetic energy, the main expression is Ke is equal to 3 by 2 nR and T. So which is exactly the same concept. It's just nR. So I'm gonna mathematically solve this question. So I know I have to get rid of my T, so I'm gonna make T as my subject in the ideal gas law. So T is equal to PV by nR. So now this is the value I'm gonna substitute in the place of T, the expression. So Ke is equal to 3 by 2 nR. So I have PV by and R. So I'll have my this variables cancelled out and R, and I'm gonna be only left with the expression KE is equal to 3 by 2 the pressure times volume. So now I can directly implement this expression into my question, since throughout the statement they only mention pressure, volume, and the moles. These are the only three things that are being changed and mentioned in this question. So let's solve this, but we also must note that we will kindly ignore the change in moles because they do not affect the total kinetic energy of molecule. Only the temperature is affected. As we know that also in this ideal gas formula, that pressure and volume is dependent on temperature. So that's why we're just going to consider the pressure and volume and just leave the moles out. It does not affect. So let's move to statement one. It says changing the volume of hydrogen from 1 mole to 1.2 mole while keeping the pressure and volume constant. So as we know that moles, will ignore the moles, it does not affect the temperature, as we know that pressure and volume is proportional to T in this ideal gas line. Similarly, in total kinetic energy, we had the moles and R cancelled out, so it just leaves us with pressure times volume. So this statement is wrong. This does not affect the total kinetic energy as the pressure and volume are kept constant. So the kinetic energy is also constant and it's unchanged. So moving to statement two, changing the pressure from 1 atm to 1.2 atm while keeping the volume and number of moles constant. So yes, the pressure is actually being changed from it's being increased while keeping the volume and number of moles constant. So even though the volume is kept constant and we just ignore the moles, the statement is still valid. The pressure is being increased, so the kinetic energy will also increase. Statement 3, changing the volume from 1 liter to 1.2 liter while keeping the pressure and number of moles constant. So yes, this does also increase the kinetic energy. As we know that there's increase in volume, the volume is being changed, so the kinetic energy is also going to be changed, even though the pressure is kept constant and we kindly ignore the change in number of moles. So the only statement correct are 2 and 3 statement. So that's how we solve this question. So thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.